Okay, so Pluto's a weirdo dwarf planet, right? It used to be considered a regular planet, but then some smart folks like Neil deGrasse Tyson and Myoka came out and said that Pluto might actually crash into Neptune. How could that happen? And what if it did? Is this a rare space thing, or is there more to it? Let's look into the possibility of Pluto and Neptune hitting each other. Pluto got demoted to a dwarf planet partly because it has a weird orbit. Scientists now think Pluto's path is super close to Neptune's, and Tyson and Myoka are worried they might smash into each other, which could be bad news for Earth. So, why is Pluto's orbit so strange? For one, it takes Pluto 248 years to go around the Sun once. Also, its orbit isn't round like the other planets, it's more like an oval. On top of that, Pluto's path is tilted compared to the other planets, making its orbit even more unusual. Here's a crazy thing, Pluto's path crosses Neptune's. For about 20 years of its orbit, Pluto's closer to the Sun than Neptune is. So, why haven't they collided? Well, that has to do with gravity from other planets in space. People started studying Pluto's orbit right after it was spotted. At first, they didn't quite get it. It was different from all the other planets. The fact that it crosses Neptune's path made things even stranger. The fact that Pluto's orbit is stable despite all this mess shows how complicated space stuff can be. Imagine three objects like Pluto, Neptune, and the Sun all pulling on each other with gravity. It's tough to predict where they'll all end up. This problem helps explain how the paths of Neptune and the Sun affect Pluto. Some terms that pop up are vibration and latitude vibration. What this means is that every time Pluto crosses Neptune's orbit, it's far enough away from Neptune that they won't hit. Latitude vibration is about how Pluto moves up and down in its orbit. So, when it's closest to Neptune, it's way above the other planet, keeping them from crashing. Then there's something called the VSSK oscillation. Basically, it's about how three objects, like Neptune, Pluto, and the Sun, tug on each other. This oscillation helps to understand why Pluto moves the way it does around the Sun. It keeps its path steady and smooth over time. All these things work together to keep Pluto from hitting Neptune or flying off course. Back in the 80s, some computer simulations showed that Pluto's orbit is actually pretty chaotic. A small change at the start could make a big difference down the road. Still, these crazy properties keep Pluto stable for a seriously long time. Recent tests using computers helped us learn that big planets like Neptune, Jupiter, and Saturn have an impact on Pluto's route around the Sun. Neptune and Pluto have a special relationship. For every 2 trips Pluto takes around the Sun, Neptune takes 3. This keeps Pluto steady. Jupiter's gravity assists, and Saturn helps a little too. These show that Jupiter's gravity is strong enough to keep Pluto on a stable route for a very long time, like billions of years. So Neptune, Jupiter, and Saturn all team up to keep Pluto safe. All of this is important for keeping space in order. Without these things, our solar system would be super chaotic. Planets could crash into each other or get thrown out of their orbits. Knowing about Pluto's orbit, especially with people talking about it crashing into Neptune, is a big deal. We get a clearer sense of how space works. Pluto's situation shows that even orbits that look unstable can find balance because of gravity and how things move in space. It also shows that we have to keep watching and learning about this stuff so we can understand where we fit in. Figuring out how space works turns up weird stuff, like Pluto's orbit. Sometimes orbits seem messy, but that's just how sensitive they are to where things start in relation to each other in the first place. Even tiny changes in Pluto's location or speed can affect its path over time significantly. Putting all that into computer programs helps scientists work out how Pluto travels. These programs utilize tricky math to copy how the Sun pushes and pulls space stuff like Pluto and Neptune. By tinkering with things, stargazers can find out how even tiny adjustments can rock Pluto's path. These programs expose the fact that even though Pluto has U vibration and latitude vibration to keep it still, its orbit is still wild. Even if you begin with a tiny difference somewhere on Pluto, its route can turn out wildly different over the years. But even with all this wildness, Pluto's journey stays steady for billions of years. This means that Pluto's trip around the Sun has some order, even if it seems all over the place at first. It is hard to guess where cosmic events will happen, especially for weirdo bits like Pluto's. These unpredictable systems mean that long-term guessing is hard. While computer programs assist in figuring out what might happen to space objects, they highlight the limits of what we can guess. Any mistakes can cause results to be way different, making guessing the future a daunting task. These messy orbits tell us that there's a lot we still don't know. Seeing how gravity affects Pluto's orbit teaches us a lot about our solar system. It shows how each planet can change the balance and paths of other things in space. So why are Neil deGrasse Tyson and Myoku bringing up this potential crash with Neptune now? Tyson is good at explaining space in easy-to-understand ways. He helped take away Pluto's planet status. He makes good points about how it changes the more we learn and how fascinated the public is by the unknown parts of space. Tyson supposes learning is always happening. He sees Pluto's orbits puzzles as an example of how there is still so much to figure out. Myoku focuses on space forces. Cox is known for helping people understand hard, steady ideas as they relate to what might happen in the future, making him a valuable part of talking about how things move in space and what that means for people. Cox suggests watching and guessing future space events with computer programs to plan and comprehend what could occur. He considers space interactions as a critical place to learn, not just to be curious about them. He says we need to be ready for the chaos of space. Tyson and Cox agree that space is endless and that we don't know everything. They emphasize that the need to explore these things needs continuous modeling techniques. Both seem that Pluto crashing into Neptune presents a problem that demands attention in space study. To know these mysteries requires constant questioning, research, and innovation. Most scientists agree that Pluto and Neptune's orbits will remain safe for the time coming. The possibilities may be rare, but these researchers highlight why it makes sense to study potential space collisions. Continual monitoring of bodies in our system will ensure better preparation for the unforeseen future. Studying Pluto's orbit opens space talks about keeping our solar system safe. All space junk travels around without ever crashing, which demonstrates how these parts of the solar system create harmony. However, there is always the possibility that forces in space shift and knock what we know of a space-safe atmosphere askew. Without these things that keep the planets from crashing into each other, our solar system would be way more chaotic. Planets could collide or get thrown out of the solar system. So, it's really important to understand Pluto's orbit, especially with people talking about a possible crash with Neptune. It helps us see how our solar system works. Pluto shows us that even orbits that seem unstable can find balance because of gravity. It also shows why we need to keep watching and learning about space to understand our place in the universe. Space is unpredictable, and Pluto's orbit is a good example. Even small changes to its speed or location can change its orbit in the long run. Scientists use computer models to study Pluto's movements, including how space objects impact each other. By messing with these models, scientists can learn how little differences in objects affect their course. These models, which came out in the 1980s, revealed that there can be small differences in how predictable Pluto is. But even with all the chaos, Pluto continues to have a stable orbit for billions of years. It's hard to guess what will happen in space, especially with chaotic orbits like Pluto's. These things are so unpredictable that it's difficult to guess the long-term future. These models are great tools for understanding space objects, but are limited. Small oversimplifications in models can eventually lead to vast differences in results. Cosmic events like Pluto remind us that it is difficult to fully understand the universe. Looking at the gravitational effects on Pluto's orbit can shine a light on even bigger solar system interactions. Looking at the location of each planet can have far-reaching effects, impacting the course of objects within the system. So, why are astrophysicists only now worried about a collision between Pluto and Neptune? Neil deGrasse Tyson, who is known for being a key contribution to astronomy, is sharing his perspective on the mysteries of space. Tyson has been a key figure in reclassifying Pluto as a dwarf planet, and views the current state as an adaptation to the growth of our solar system knowledge. His position is that with more knowledge comes more questions, pushing us to grow further. Miyoku, another physicist, shares unique insights on the unpredictable forces that shape our universe. He has the ability to bridge both complex science and future visions, making him important in cosmic discussions. Kaku shares that we need to constantly observe with advanced technology to understand future cosmic events. The potential collision between Neptune and Pluto reminds us to look for more than just curiosities, and to look for practical implications too. This pushes us to plan for the broader implications in space. Both individuals converge on the idea that space is an infinite discovery, and that our current understanding is vastly limited. The both highlight the need for constant exploration while also adapting to new information as it emerges. There's a general agreement in the scientific community that for now, Pluto and Neptune's orbits are stable because of how they move and the gravity affecting them. So, a direct crash is very unlikely. But, because space can be complicated, astronomers need to keep watching and studying these objects to understand what they'll do in the future. Even though a Pluto-Neptune collision is unlikely, it reminds us to keep doing research in astronomy. Better telescopes and computer models will help scientists make better predictions, so we can stay informed about our solar system. Tyson's view on Pluto's reclassification and Kaku's thoughts on the unpredictability of space both show why we need to keep exploring and be open to new ideas. This possible collision case highlights the complex interactions in our solar system, but reminds us that many territories are still not charted. By continuous observation, we work to understand every corner of the universe. Studying Pluto's orbit gets us thinking about the entire solar system's stability. The relationship between Neptune and Pluto reminds us of the balance between every object in space. Every planet, moon, and dwarf planets has some harmony which challenges our understanding. Astronomers have a difficult task to predict long-term behavior of space because small changes can impact events in space in just billions of years. All combined with cosmic forces, these ensure balance long-term. But, something like a small orbit change could potentially shift this balance. Because of this, scientists need to keep growing their models and studying far planets, ensuring that they are prepared for any rare cosmic shifts by continuous observation and understanding.